Later on in the 80s, we find this whole notion of object-oriented development. It's been around a little bit before then, too, as a theoretical concept. But basically, we don't view programming anymore as just functions. Do X, do Y, passing in parameters. What we find is object-oriented programming focuses on the objects themselves, such that we are going to have cars or students, and we could say move forward for a car and move forward for a boat, and the system will know exactly what we're talking about because it's going to do it on that particular object. I don't want to get too deep into object-oriented programming. We could spend hours just on that alone and teach a separate course on that. But the whole concept is we're thinking about things differently. Instead of thinking about programming in terms of the key functions, we're thinking about objects. What does a car do? What does a student do? And creating these little components just dedicated to a car that have what's called a state and a behavior. The state is what are the features of the car, make, model, year, and what can we do with that car? We can move forward, move backward, we can start it, we can stop it. As opposed to boat, which will have a different state and a different behavior. Even though they might actually be the same, it will be done differently. Moving forward, both a boat and a car does, but they're ultimately going to do it differently. Client-server and web-based development. In the 90s, we started seeing these client-server applications where we put an application on the server and we have a client as well that actually does some work. And the whole concept here is network-centric development, that we will put a piece of software on a client's computer, either thin client or thick client, and connect to a server that will do some, if not all, of the work for us. And this allows us to do things a little bit better because what happens is that, especially in the case of web-based development, we don't have to deploy software on every client computer. We can basically just deploy it on the server, and the server will know what version of code is needed for a particular client. So we have reduced maintenance costs, we have easier implementation, and it's just a far better way to work. Plus, everyone knows how to use a browser, so there's a different learning curve that's needed. How to start the application, where do you go in the application? We can create similar look and feels to things that are generally known. So underlying these trends is the increasing use of packages and system integration. It makes it easier to do that. As much as possible, companies prefer to buy a package rather than build an application in-house. I'd rather buy certain things and put them on the server, and this is true of web-based development, than actually build it in-house. So you have the whole notion of this buy versus build. But what we can do is we can extend this a little bit to say, well, it's buy versus build, but it's also versus acquire. Because if we buy it, it assumes we're going to actually lay out some cost for it. If we build it, we're also going to lay out some cost for it. But acquire is a little bit different because acquire basically says we can actually go get a piece of software that's free, such as open source code, and try it out. It's great for prototyping, and it's great for us to take a look and say, hey, you know what? Maybe this is what we want to do. We want to just try it out, see if our assumptions are correct in terms of the workflow, and we'll use the this Salesforce application, say Sugar CRM, which is open source. Try it out and see if it works for us. And if it does, we can continue using it. And if we don't want to use it, then we can go out and buy an application because we generally know how this type of system will work with us. So to develop the large applications, you have to integrate various hardware and software components. So all of these things need to be taken in consideration when you're doing any type of web-based development. So in summary, the technologies, you had structured development, 4GLs, prototyping, computer-aided software engineering case, object-oriented development, client-server systems. And everything is kind of used in some way, shape, or form today. We now turn to that in today's environment, beginning by discussing the main method of building systems, and that's integration. So the next module, we're going to focus on how these things integrate, because it's great that we can build something and build something over here, but now we have to figure out the complexities of integrating them together. So that's the end of this module. I'll see you for 9.2.